we did this under the title Cooperation in Education. And we would like to introduce what we did here in our courses at different levels. Should I go on with this first?
Yes.
Okay. So, who's operating this? So I would like to remind you one more time to what we were doing here. Cooperation in education, environmental hydraulics, field training reach, etc. We established common field training reach, about 25 kilometers, goes across the border. We introduced the latest advancements in field data collection techniques, processing, data analysis, etc. And we introduced state-of-the-art, not yet completely 3D is unfinished, state-of-the-art 1, 2, 3D mathematical models for flow and transport processes in natural rivers. Are you still translating or not? No. There's no need for that. Okay. So, as far as Subotica school is concerned, we have a number of courses which can use these results right away. So improving curricula, improving data that we use for assignments, student assignments, research at the higher levels, etc. So this is the list of courses that are influenced by, that can use immediately these results to improve their curricula. We have PhD courses, measurement principles, which is things like measurement errors, error analysis, possible sources of error, etc. Generally, we have course of field measurements. Then we have a few other experimental, but those are related to the topic. Then we have computational courses. Fluid dynamics is 3D modeling, computational hydraulics, open channel flows 1D models, and 2D models. We have sediment transport morphological processes. All of them will benefit from these results. We have master level courses, general measurements in hydraulics water resources, which have a significant part that's related to this topic. So river, discharges, velocities, etc., sediment samples, etc. It's not only this, but it's like half of this course. We have open channel flow and transport processes at the level of master course, which gives an overall review of something that's at the PhD level has focuses each topic. And we have river hydraulics morphology talking about 1D modeling. And then we have, at undergraduate level, we have hydraulics 2, which is actually computational hydraulics, open channel flow computational hydraulics, and river hydraulics morphology, etc., which goes after this one and uses mathematical modeling, etc. All these courses results will provide immediate impact on curricula. We can include results, we can add topics, we can add new assignments to students based on this, etc. As you can see in the previous slide, as you saw on the previous slide, there is more of that on master and PhD level than basic undergraduate level. So we are working on, and this is work in progress. We've been working on this for a couple of years, and we'll work for another year or so. Introduce changes in curricula, undergraduate curricula. We have two elective courses: water quality and water protection. First one focused in the past on chemical, biological, water content, water quality, typical water quality course. We would like to add flow, sediment, morphological aspects. We would give it a new focus on field measurements, something similar to what we were doing on this project, and maybe call it water monitoring. If we had something like this, this time we would have, as elective course, framework to bring legally our students. Now our students were brought, not illegally, but under something else. We had to bring them under cover of practical, whatever, experience required, etc., etc. But in the future, when we finish this, we will have a framework. If students decide to take elective course like this, then they would be signing for the course, etc., etc. And we'll see how to further enhance this by possible cooperation, future cooperation, exchange of students, etc. And there is also idea that existing course water protection, which mostly talks about pollution, water pollution sources, etc. Add to it mathematical modeling of flow and transport processes. And we are not looking only at pollution sources, we are looking at sources of pollution and transport of pollutants or fate of pollutants, what happens with them when they come to the water. Tentative title, doesn't matter. Pollution sources and transport or something like that. Next one. How can we go on further with this cooperation? First of all, we would like to keep this sector as a continuous training research center or whatever, research ground for our schools. We could introduce intensive courses in area of field measurements, mathematical modeling on both sides. We can exchange students. We can say, okay, if, let's say, BIA has a strong field data collection course, we can include our student through our course, which would be, let's say, water monitoring, river monitoring, whatever we call it. We can organize similar courses in mathematical modeling, include students from BIA, etc. And that would be based on exchange of teachers and students through appropriate programs. We look for those programs, whether we can use Erasmus or something similar. So those were my ideas on future thing, and also information on how we will use in Subotica, how we will use what we have achieved on this project, the results of this project.
So it's my turn now, I think. But now I should begin my part of the presentation. That I am speaking about something that is work in progress, because the curriculum development is really the last thing in this project which can be done, because first we have to do the measurements, the analysis, and also the evaluation of all the work we have done, and after that there is the time to make changes in our educational program to include all the benefits of the project which is still not ended. So I can just very shortly and briefly tell you that in our college in AEF we have a very big tradition of taking the students to field measurements. So we have actually 3 different types of field measurements programs throughout undergraduate level courses. That means that when the students receive their BSc diplomas, they already have participated 3 times in field measurements, 1 week each. The first is on surveying, that means geodesy and hydrogeodesy. And the second one is hydrometry. And the third one is hydroecology and water quality components, something like that. And now, after this project ended, we would like to propose a very big improvement to our own field measurement programs to integrate these 3 components together, and not to remove the existing 3 types of field trainings, but to put one more, maybe as an elective course. It's not yet decided. It will be something like advanced field measurement technologies, or something like that, and to have the possibility for the students to participate in international multidisciplinary field work, hopefully at the same data ranges or the same reach of the river Danube that we use now. And for this, we are in the process of developing some short program based on our experiences, what can be done in a day, for example, and how to accelerate a bit the data processing to have usable data sooner than it happened to us now in the project, because this was experimental case, and now we are trying to improve our methods. And only thing I can physically show you, it is a big step, that we have already something like a sampling, surveying and measuring handbook that is intended for students. It is almost complete, not yet ready of course, and it is now available in 2 languages. It is almost completely translated already into Serbian, but we will ask our colleagues in the GFS to control the translation. Maybe some of the special technical terminals are not used the same way. So I can show it to you. If somebody is interested, you can have a look and see the level of details and things like that. We also attached the sample protocols in it and also the sample data which are measured during the project. And I think it is a very useful tool, because we would like our measurements and the whole fieldwork to be reproducible. So the methodology must be standardized somehow, and this is the first time that we are doing something like that. So this is the time to put down these principles. And if you have any questions concerning development of this curricula, or the changes, or the existing ones, I am happy to answer. Thank you. So I will put it here somewhere, here, for example. We will finish soon the official part of the meeting for today, so if somebody wants to have a look, it's here. Are there any questions?
Yeah, I see 2 problems with the student exchange, maybe 3. First
Yes.
of all, we are not, it's not eligible for us to take part in the Erasmus program yet, that's first. The second is the language barrier. And the third is that the curriculum of your institution is completely different than that of ours. You are doing practical things like measurements, which is of course very important in our curriculum. But your students should start to learn the numerical simulation, which I can imagine just on the master's or the PhD level, not on the BSc level. So
How to override these difficulties?
concerns.
So I can answer all the 3 questions or problems. First is that Erasmus program, some parts of the Erasmus program are already available also in Serbia. For example, Erasmus Mundus is already here, and soon intensive programs will also be available. So it is not a question of immediate action, but we are talking about the future, and hopefully in the near future, and as I know from different sources, it might be the question of 2 or 3 years, and you would become full partners in the Erasmus program, and then we can use this possibility for the exchange of students. But until then, we will try to find other different sources of funding and try to prepare another project proposals and try to get the funding for this type of exchange and development and research projects in the future. For the second, for the language barrier, I think that this is a thing that must be solved not only by us but by everybody in the region, because of course not everybody speaks Serbian or Hungarian language, but most of the people do speak either one of them or both of them, and this is how with some translation we managed. But I think that officially the language of this type of courses should be English in the future, and I could select approximately 20 or even more than 20 BSc students who spoke English well enough to understand this type of presentation, so I think that it is not so big problem. And For the modeling, I have to tell you, and I forgot to tell previously, that we have actually numerical modeling courses, and we have courses on 1D modeling in the BSc level. And they are doing it as it is an official course. It is not an elective one, but it's an obligate course. And maybe, because my students are here, maybe they can answer better what they are learning in this field.
Can I also add a little bit in that? See, both measurement courses and, let's say, even field measurement, or computational courses can be taught, and they are taught in our school at all 3 levels. When we are talking about undergraduate courses, then we teach them most frequently used stuff. So, when I started teaching that 15 years or more than that, 20 years ago, I put everything in a numerical course. Then I started cutting down. Like there was water hammer on undergraduate. There was, of course, this when I'm teaching open channel flow, etc. Water hammer, unsteady, pipe flow, etc. It's not very frequent problem. So undergraduate level, we can leave that for higher level. However, 1D unsteady flow, 1D unsteady open channel flow is something that everybody today runs into when they start working. Go to the company, they put the computer in front of you and give you hackras. And you have to go through it. So in that sense, what's taught in Subotica is, for that, the mostly used type of modeling is you have to know equations, what that type of models are based on. You have to know assumptions under which those equations are developed. So the range of validity of that kind of model, you cannot use it in a situation where assumptions do not apply. You have to produce some results, you have to compare it with some measurements. You have to evaluate your results when you press the button and the model. So we don't teach them just to put data inside and the old saying says garbage in, garbage out. Put something in, something comes out, and you trust the number. You have to evaluate those results, whether your elevation that you're computing is about where it should be, where some measurements show, or whether it's 2 meters lower or 1 meter higher. If it's 2 meters lower and you are designing dikes, flood protection dikes, then when the real water comes, it will flow over. If you are a meter higher than that, then your dikes will be a meter higher and extremely expensive. Things like that. That without going into too much detail, what's left for higher levels. When I'm teaching that at the master level, I expect more. At the undergraduate, I'm a leading student through all these steps. I expect more of your own students' own work in that, and more of his thinking, how he manages to do similar kind of stuff with something that's not, he has to go through details. I give him the framework, but he has to go through details. He has to show that he can deal with that kind of modeling by himself, with less help, with less guidance than undergraduate studies. On PhD level, students have to write their own programs, develop, etc. A similar thing goes for field measurements. Undergraduate levels, you guide them. They work as a team. The team has a leader. The team leader is somebody from staff. And they learn how to join similar team. Tomorrow when they're done, they will have another team leader and will be able to reproduce what they learned under the team leader who was teaching them in the school. At master level, they should be able to do it by themselves. That kind of a level that is similar to the team leaders' organized work, tell other people what to do and things like that. PhD level, they have to design their own measurement techniques. They have to design their own experiments. So each of those could be used, could be taught on each level. We go up from one to another.
Can I add something to the language problem? Which I forgot. That it is a very big fault of mine that I forgot to tell in the beginning.
I'll add something after you.
Because it is a cross-border cooperation between Hungary and Serbia. Within the horizontal objectives of the project, one of the important points was to promote Hungarian and Serbian bilingualism in the region. So in that sense, this manual is the perfect thing we could do, because it is a bilingual manual for executing of these measurements. So I think that this is what the project leaders wanted from us.
The best thing is after those measurements, there is dinner at Pickett's, and at Pickett's after 2 beers they start speaking. They communicate very well. We learned that and see that. Yeah, Esperanto. Okay, any questions on this? Well, if not, then you have some time since you traveled. Those who are staying, those who are traveling, we would like if you could stay, but who are traveling will have time to travel back. Those who are staying will have time to rest a little bit. Dinner is at 7. Downstairs.